Here's another example for units conversion. We're going to work out how much energy a human body uses in a day in kilowatt hours. So we had previously shown that the power of a person is about equal to 100 watts. Remember that we did this by taking a look at the recommended daily food intake of a person in a day, which was the US RDA for food is about 2,000 food calories, and 1 food calorie, which is written with a big C, is 4,184 joules. And these are unit conversion factors that you can find online or in your book, or will be provided to you in an exam. You don't need to memorize them. And so that means that the total energy consumed by a person in a day just to keep the body going is 2,000 calories. And we do a units conversion from calories to joules. So we're going to multiply it by a unit conversion factor. So I always start by writing 2 big parentheses and a line. So I'm going to have one number on the top and one number on the bottom in different units that are equal to each other. So for example, here I want the calories to be canceled out. So I'm going to put 1 calorie down here, and I want my answer in joules, so I'm going to have the number of joules that's equal to 1 calorie at the top, and that is 4,184 joules. And so the total energy of a human body over the course of a day is 2,000 times 4,184, and that gives me 8,368,000, or 8.368 times 10 to the 6 joules, because the calories here cancel, and I'm just left with that number of joules. And then we calculated the power of a person over the course of a day was that number. It's the amount of energy divided by a interval of time. That's the definition of power. Okay, that is something you need to know, is 8.368 times 10 to the 6 joules divided by the amount of time in a day, and our SI unit for time is the second, and the number of seconds in a day is 86,400 seconds. That just comes by taking 24 hours times 60 minutes in an hour times 60 seconds in a minute. That gives you 86,400. And so that's what gave us this number of approximately 100 watts. I divide that 8.368 times 10 to the 6 divided by 86,400, and I got 96.85 or 97 watts. So that's something we did in class. Now what I want to do is calculate what is the energy used by a human body in one day in kilowatt hours. That's this other unit of energy that is primarily used for selling electricity. So this is a unit of energy. Notice that it's a power, kilowatts, times a time. So power times time equals energy. So I don't need to worry about this 97 watts. That's a review. I can go straight from my total amount of energy here, 8.368 times 10 to the 6 joules, and then I need to convert that to kilowatt hours. So what's the conversion factor from a joule to a kilowatt hour? Okay, well, I can look up that number in my book and see what it gives me for conversion factor between joules and kilowatt hours. And what do I find? Big energy numbers. 1 kilowatt hour is equal to 3.6 megajoules. I want the joules to go away, but my conversion factor is given. This means 1 kilowatt hour equals 3.6 megajoules. So I'm going to put 1 kilowatt hour and 3.6 megajoules. That's 3.6 times 10 to the 6. Mega is times 10 to the 6 joules, and that's my unit conversion factor. So the joules again will cancel. The 10 to the 6 will also cancel, and that will end up then just giving me 8.368 times 10 to the 6 divided by 3.6 times 10 to the 6, and that gives me just 2.3 kilowatt hours. So 2,000 calories is about 2,000 kilowatt hours. That kind of tells us that 1 food calorie is about equal to 1 watt hour of energy. This 2,000 here, it's 2,300. So that's just a coincidence there. 2.3 kilowatt hours, that's the amount of energy it takes to make an electric car go about 8 to 10 miles, depending on the efficiency of a car. So it just gives you another way to think about the amount of energy it takes to keep the human body running. Remember that the amount of energy used by a human body in the United States is only about 1% of the total amount of energy that we consume going about our lives because of the various things we do in terms of transportation and use of electricity and all the other things that we do.